So we're going to plug in our test points now. So I'm going to take this -2 and plug it into the derivative. Man, drives me crazy. Okay, so f prime of -2 is equal to, so it doesn't matter which side I put this on, -2 times 2 plus 2. Now what we're concerned about here really is not the number, but if this is going to be a negative or a positive. That's all we're really concerned about here. So you have -2 times 2 is a -4, and -4 plus 2 is -2. So this is a negative number. So we're going to say that this is negative, and I'm going to draw a line indicating that the graph is decreasing between -infinity and -1. And then what we want to do is we want to go ahead and plug in our other test point, which I said was 0. So we're going to have 2 times 0, 2 times 0 plus 2, and that's going to be 2, so that's positive. Right, so plus sign, I'm going to put a plus sign here, and that means that the graph is increasing. So we have decreasing and then increasing, so you can see here that this is going to end up being a minimum, a relative min. Okay, this is going to be a minimum at -1. And so now what I'm going to do is I'm going to plug in what is f of -1. We want to get the point on the actual graph here, and that means that we're going to have to remember what the function was. That's going to be x squared, so that's -1 squared plus 2 times -1 and then minus 1, right? And we want to do the math on that, and we should end up getting -2 out. So we're going to end up having a min, and I'm going to write it as a point. It's -1 comma -2. All right, and I'm going to go ahead and add this, that this function is increasing, or we'll say decreasing, and I'm just going to label DEC for decreasing. It's decreasing from -infinity up to -1, and it's increasing from -1 to infinity. And we can see that just by looking at this graph right here, okay, that the function is going to be decreasing from -infinity to -1 and then increasing from -1 to infinity. And of course, if you go back and look at the graph, you can actually see this. Now remember that this is a relative. It's relative to that one little area right there, even though it is, in a sense, it is an absolute. But anyway, okay. Let's move on to another problem. Okay, let's see here. We've got f of x is equal to x squared minus 6x. So let's work it out first and then look at the graph. So the first thing we're going to do is find those critical numbers. That is, we're going to take the derivative, set it equal to 0, right, and solve for x. So it looks like that if we plugged a 3 in right here, 2 times 3 is 6, and 6 minus 6 is 0. So our critical number is going to end up being 3. And so what we're going to do here is we're going to draw us a graph, put 3 here, and then we want to pick some test points, and I'm going to always pick 0 because 0 is the easiest thing to pick, and then we'll pick 4 right here. So then we take our test points and plug them into the derivative and see if we get positive or negative. So I'm going to take 0, plug it in up here. So 2 times 0 is 0, but then we're left with a minus